So today we're going to be doing question 3, chapters 1 through 2. So we're going to start off with part A. And part A tells us that we are throwing a rock straight up from the edge of a cliff, and it's leaving our hand at time is equal to 0, moving at around 16 meters per second. So from the bat, we have time is equal to 0 as it's leaving our hand. And then 16 meters per second is going to be our initial velocity. So we need to find both times at which the rock is 4.00 meters above where it left my hand. So let's diagram this out. Let's see this. Let's say I'm right here, tossing a rock just from a cliff, just tossing it up, arcing around. And let's say from where my hand is, right over here. We're going to make a little XY graph. And we're going to say that I want to know around 4 meters above my hand. I want to figure out what both times is this rock going to hit 4 meters above my hand. Okay, so we're going to use kinematic equation of y is equal to y initial plus velocity initial times time plus 1/2 of the constant acceleration, which on the y will be gravity times time squared. So when we plug in our known values of what we have, which is 4.00 meters for our y, this is what we have to reach. Our initial is going to be 0, as that's where it's leaving our hand from. Our initial velocity will be 16 meters per second times time, as that's how hard we're throwing the ball, plus 1/2 of negative 9.8, which is our constant acceleration of gravity, times t squared. So what we see right here is pretty much just a pretty basic quadratic formula, which we can just simplify really quickly. So 1/2 negative 9.8, that 1/2 is going to pretty much make this 4.9. We have negative 4.9 t squared. So we're then going to subtract 60 meters per second onto the other side. And then we're going to add 4.9 t squared onto the other side. So we're going to be left with 4.9 t squared minus 16 meters per second. And do not forget that as well, since this is an acceleration, it will be 4.9 meters per second squared, t squared, plus 4.00 meters is equal to 0. So now that we have our quadratic formula here, what we're going to be doing is using the quadratic formula to pretty much solve the equation. So we have A, B, and our C. So B, negative 16. Actually, let me write it out just so you know that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So negative of the negative 16 is going to be positive 16 plus or minus the square root of negative 16 squared minus 4 times 4.9 times 4. 4.00 all over 2 times 4.9. So when we simplify this, we're going to have 16 plus or minus square root. I'm going to have a calculator here to show. 16 negative 16. Squaring that, we get 256 minus, now let's see, a squared 16 would be 16 times 16, which is negative. It's always equal to a positive, so it makes it positive. 726 would be 4 times 4.9 times 4 is equal to It's a little hard to see, it looks like 0, but it's 78.4. So it would be minus 78.4 over 2a, which since we already had this divided in half, we know it's going to be 9.8 either way. So it's 9.8. So 256 minus 78.4. There we go. So it'll be 177.6. So it's going to be 16 plus or minus square root 177.6 all over 9.8. Should we square the root that? Look at 16 plus or minus 13.33. So yeah, 8 plus or minus, and we're looking at 9.8. So now that we finally have that, this would be our exact form. Technically it would be both 16 plus 13.33 and 9.8, but we want our exact numbers here. So we're going to be doing 16 plus 13.33 divided by 9.8, which is going to give us 2.99. So our first time is equal to 2.99 seconds. And then we're going to do 16 minus 13.33 this time. And we'll divide that by 9.8. And our second time will be t is equal to 0.27 seconds. So when we throw this ball at 0.27 seconds, it's going to reach that 4 meters, and then it's going to arc, go around, and around 2.99 seconds, it will finally come back down and reach that same point again through its path. So their answer for part A will be these two answers, these 2 seconds. So that's for part A. Now let's go on to part B. Now this time it's going to change things up. Instead of asking for above our hand, we're now going to be asking for 4.00 meters below our hand. So same thing. Let's visualize this because it makes it a lot easier to know what we're really looking for. Because when you see this right here, we understand that it's going to be looking for 2 different answers to the problem. Now, if let's say we're throwing it again, visualize it with a 2D graph because we know that we're moving around. So our hand right here is at 0. If we want to look for 4.00 meters below the hand, that means that we're going to have to go down. It's going to be in a negative value. It's going to be negative 4.00 meters. That's going to be 4 meters below our hand. So we can see right here that's going to only hit it once. We're only going to be able to find one answer to this problem. But either way, these steps are going to be the same, and we still have to do it algebraically to be able to figure out what is the exact answer. So same numbers again. We're going to be using this equation all over again. But this time, since 4.00 meters is below our hand, it's going to be a negative number. So negative 4.00 meters is equal to pretty much our y initial 0 plus 16 meters per second plus our 1/2 of our constant acceleration, which is negative 9.8 meters per second squared times t squared. Okay, so we're going to be doing the same steps pretty much that we repeated here initially, which getting 4.9 and then adding everything over to the other side. We're both subtracting 16 and then also adding our 4.9. So we're going to be left with an equation of 4.9 t squared minus 16 m second t minus 4.00. And pretty much it's just repeating the same process again. But this time we have a negative number, so it's going to alter our question a bit differently. So Same thing. 16 plus or minus the square root of 16, which we saw was 256. So we'll just put that over there. 256 minus 4 minus 4, 4.9, and this time it's going to be also multiplied by negative 4.0 all over 2a, which is 9.8. Now, it will be the same pretty much answer, but this is negative. We have two negatives multiplied to each other. It's going to turn this positive. So they won't be subtracting each other no more. It will now be 256 plus 78.4 all over 9.8. So if we bring our calculator back, 256 plus 78.4, we're looking at 334.4. And then I'm going to just square root that already so that we can find what our answer. So we're going to be looking at 18. So it's going to be 16 plus or minus 18.29 rounded over. That'll be all over 9.8. So we have to figure out which one is going to be our right answer for this section right here. So let's do 16 plus 18.29 divided by 9.8. It's going to give us 3.50 seconds. All right, now always have to make sure that we are correct about things. So we always have to make sure that you find out the rough estimate of both of the problems to make sure which is right. So we're going to subtract them and then divide it by 9.8, which is going to give us negative 0.23 seconds. Now, we can only have one answer. And the thing is, time cannot be a negative number. Not showing it here, but there it is. Time cannot be a negative number. It can never be negative as you can't go back in time. So our only possible answer is to take this right here, the 3.5 seconds. So in 3.5 seconds, the rock will then reach negative 4 meters below our hand. So that's it for part B. Let's move on to part C. Moved it a little bit. All right, let's go to part C. So this time it's going to be asking us, let's say we're throwing a basketball, and we're going to be throwing it straight down. Basketball straight down. And we're throwing this at around 9.00 meters per second. And we want to figure out when the ball is going to be below 5.00 meters. So keyword below. All right. So I am at a roof of a building with a basketball for a reason. And I am tossing this basketball down. It could be working just all the way down here. So pushing it, velocity of 9.00 meters per second. And I want to figure out from my hand that I am throwing it, keyword XY, Y, I want to figure out when it will be below my hand, which is 0.0. So when it will reach 5 meters, at what time will it reach that? So it's going to be the same process as the last two questions. Or you have negative 5.00 meters is equal to our initial, which is 0 meters, plus 9.00 meters per second times time plus 1/2 of our constant acceleration, which is going to be gravity times time squared. Same process. It's going to be 4.9, and this is going to be 2.0. So we're going to move everything over to the side, add this, subtract that, and we're going to be left with 4.9 meters per second squared. T squared is subtracted by 9.00 meters per second time minus 5.00 meters is all equal to 0. So we're going to take this, do the same thing, quadratic formula to figure this out. So we're going to put ourselves over here. So we're looking at -9. It's going to be 9 plus or minus the square root of 9 squared minus 4 times 4.9 times 5, -5. There we go. All over 2 times 4.9, which could be 9.8. All right, so let's bring the calculator again. 9 squared, 81. So we have 9 squared is equal to 81. And that would do 4 times 4.9 times 5. And we're going to get 98. So same thing as the part B. Since we have two negatives right here multiplying, it's going to turn this to positive. So we're going to have 98. And as we plug these back into the quadratic formula, it's going to be 9 plus or minus the square root of 81 minus, not minus, plus 98. All over 9.8. So 98, we're going to add that to 81. We'll be left with 179. Then we're going to square that right here. It's going to be 13.38 for our answer when that is all squared. So 9 plus or minus 13.38 all over 9.8. So we know that we can only find one answer. Now, if we do look closely at what is going on here, we know that 9 is going to be subtracted by a larger number. So we can rule out that when 9 is going to be subtracted by a larger number, we'll do 13, it's going to turn out negative. So it's going to turn out negative. We can rule out immediately that 9 minus 13.38 will not work. It's going to give us a negative time, and that is not possible. So we're going to add 9 plus 13.38, going to give us 22.38. We're going to divide that by 9.8, which is 2.28. So what we're going to be looking at is that our time is going to be equal to 2.28 seconds. So when we throw it straight down, it's going to give us, it's going to take around 2.28 seconds to be able to reach negative 5.00 meters. All right. So now we're going to be moving to part D. And let's see, so part D. And what's right here? So this is going to be a multiple choice question. It's going to be asking us, so we're throwing an apple straight up. So straight up, going up, like that as well. Straight up, and it's going to be leaving our hand at t is equal to 0. So it leaves at t is equal to 0, and it's moving. Velocity is equal to 5.0 meters per second. So it wants to ask how many times does the apple pass through a point of 1.30 meters. So we want to figure out how many times we're throwing this apple around 5.50 meters per second. How many times is it going to pass through the point 1.30 meters above my hand? So we can pretty much think about how this is similar a lot to part A. Now we want to throw something above. And pretty much going to be throwing this over. So what we're going to be doing here, diagram, throwing the apple around. We know that 1.8 from our hand is going to be a little bit above it, but that still lets us hit it twice. So at 2 different times will this ball, or will this apple be able to hit 1.8 meters above our hand? So we'll be taking these same steps again, where we do 1.30. Well, actually, let's not get ahead of ourselves. We know that if we take a diagram of this and think about how it's going to be hitting 1.80 meters above our hand, we know it's going to be hitting twice. So with the multiple choice, we know that the only answer will be it's going to pass through it twice. And it's going to be going upwards once, and then the other time it's going to be downwards. So right here is pretty much the middle point where it reaches 0. So it accelerates up and then accelerates down. So it's going to go up and then down. So now our only answer would be one that states that it's going to hit it twice, once up, once down. So we just don't get ahead of ourselves, because part E is going to be asking us what will be those times. So these two are going to be connected together. So let's solve this algebraically. So 1.80 meters is going to be equal to our 0 plus 5.50 meters per second plus 1/2 of -9.8 meters per second squared t squared. So same steps as everything beforehand, just going through the motions all over it again. Pretty much -4.9 meters per second squared. We're adding that, subtracting this to the other side, getting everything on one side. So 4.9 meters per second squared of t squared minus 5.50 meters per second times t plus 1.80 meters is equal to 0. So -5.5, 5.5, so 8. 5.5 plus or minus the square root of 5.5. Keep writing 8s. 5.5 squared minus 4 of 4.9 of, get something here, right, 4.85 squared. And 4.9 times 1.80 meters all over 2a, which we know is going to be 9.8. So cover this too much, up a little bit. So take our calculator over here. 5.5 squared, be looking at 30.25. So b squared is equal to 30.25. And then 4 times 4.9 times 1.8. Actually, I got that right. To 35.28. Is that right? Let me just make sure. See. Okay, so 30.25. It's going to be 35.28. 5.50 plus or minus the square root of 30.25 minus 35.28. So 30.25 minus 35.28, which I think we can still square that, which technically now can't be negative. Let me make sure that I am doing something right here. 2.24.50 plus or minus 2.24. 2.24. 2.78. Should put some in. Okay. Yeah, still on track. Still just want to make sure that everything is right. That I'm still moving towards the same answer. So either way. So let me go back. 30.25 minus 35.28. It's going to give us square root of negative 5.03. 5.5 plus or minus the square root, or not square root, but all over 9.8. Got a little lost. I want to make sure that I was just getting everything correct here and wasn't making any mistakes in my math. But square root of negative 5.08, we're going to give this sort of an absolute value, just make sure it is 5.03. We just add an I, so we cannot square root over that. But I know if we square root it, we'll give a non-real number because technically negative isn't real. So either way, we're going to move forward as we are working for positive numbers here, as we can't have negatives. We can't have negative time. So we're going to pretty much say 5.03 square root is going to be 2.24. So 5.50 plus minus 2.24 is going to be all over 9.8. 5.50 plus 2.24. Make sure it is visible. 7.74 divided by 9.8 is going to give us first time 0.778 or 79. And then T2, we're going to be giving ourselves 5.50, many zeros, minus 2.24, 3.26 divided by 9.8. It's going to be 0.333. So these are going to be our two times right here, in which the ball is going to be crossing, or the apple is going to be passing 1.80 meters. All right, so let's move on. That is both part D and part E. That's pretty much part D is us looking at it graphically and seeing how, if we just kind of visualize this, we can see how we're going to be only finding two answers here. And then part E is pretty much us solving it algebraically. So if we move on, or actually, on over here to our next question. Part F. Part F. So it's going to ask us how many times does the apple pass through a point 1.0 or 1.80 meters above your hand? the apple does pass through this point, is the apple moving upward, downward at each of these times? So, how many times does the apple times does the apple must pass through? A point 1.8 meters above our head. Pretty much. I'm trying to read this again. How many times does the apple pass through a point? 1 point. And is the apple moving up or down each of these times? How many times does the apple pass through a point 1.80 meters above your hand? Compared to how many times the apple passes through a point? That is why. Okay. I am completely reading that wrong. Well, actually, our times are a bit different here. Okay, so let's fix our mistake over here. So I was incorrectly reading what the time or the meters was for part E, or actually part D. So we actually solved part F inadvertently, because part F is 1.80 meters. I kept reading 1.30 meters as 1.8. I apologize. I sometimes have a bit of arithmetic dyslexia and mix up my numbers. So I should actually correct this right here. This is not part E. This is part F. Both of these are part F. And these are our answers for part F right here. As this is, we're solving for 1.80 meters. Let's go back actually and do part D and E. Let's just fix our errors here and understand that we can always understand things a bit better by just rereading things. And that's okay to make mistakes. As a good thing is that we are at least attempting and trying. So, part D and E, we know that it's going to be pretty much the same concept. Throwing a ball, 0, but this time we're looking for 1.30 meters. Same thing, 1.30 meters above our hand, similar to 1.8 meters. So we're tossing this at 5.00 meters. Or not 5.00 meters, but we're looking for, go back to what it was saying. Our initial velocity is equal to 5.50 meters per second. Time is equal to 0 initially. So now let's do this. We have 1.30 meters, which is equal to the 0 initial plus 5.50 meters per second times t plus 1/2 of our acceleration. Or I will just write that normally as negative 9.8 meters per second squared times t squared. All right. Same process last time. Move everything over so we have 0 only. Be left with 4.9 meters per second squared t squared minus 5.50 meters. That's why it was confusing me so much earlier when I was looking at the math. I felt like I was doing something wrong. Negative 5.50 meters plus 1.30 meters is equal to 0. All right. So we're just taking a calculator, look back over here. How many times I have to? We know that our 5, let me check, 5.5 is going to be 30.25. So 5.5 squared equals to 30.25. So quadratic formula, 5.5 plus or minus the square root 30.25 minus 4 times 4.9 times 1.30 all over 2a. Just write that as 9.8. So take your calculator, do this the proper time actually of 1.3. I did not write it at all. Let me do that again. 4 times 4.9 times 1.3. All right. It's going to give us a much better number that makes a lot more sense, which is 25.48. So 30.25 minus 25.48, because we definitely should not have gotten negative last time, and that's why I was really confused why I was getting that, but we are fixing our mistakes and getting back on track. So 30.25 minus 25.48. Here, we're getting, whoops, that's why I got freaked out again. Just messing things up. Oops. Okay, there we go. It's going to give us 7.77. So we're going to just square that immediately. Make sure 7.77. Which is going to give us 2.79. Run that over. So 5.50 meters. For now. Plus or minus 2.79 all over 9.8. 5.50 plus 2.79 is going to give us 8.29 divided by 9.8 is then equal to 0. Yeah. 0.50 plus 0.85 seconds. And then 5.50 minus 2. Just want to make sure I'm reading everything correct here. Everything's correct. 25.48. Now, really suspicious if I'm writing things wrong. I want to make sure I'm writing things correct. 2.7 divided by 9.8. 0.28. 0.28 seconds. All right. 0.85 seconds, 0.28 seconds. So these would be our actual times for what we want. And when it will actually be reaching at 1.30 meters. Okay. So now when we look at the actual part F, so now it's asking us, looking back at the same thing, how many times does the apple pass through a point 1.80 meters above your hand if the apple does pass through this point? So it's asking us how many times would it pass through 1.80? And compared to what we were given initially, or compared to part D, part E. So we know that we have our original answers. Let's look over here. 0.79, 0.79, and 0. Actually, write that over here. 0.79 and 0.3. So, what you have to think about is confusing myself a little bit because I'm throwing myself off. These are the times that we have right here. We are comparing if it ever passes through 1.80 meters. So we have to find our max. So y which equal our velocity. Velocity. I'm going to input our times here. So let's see, let's compare. So I'm going to compare from 0.33, 0.33 plus 1/2 of negative 9.8 times 0.333 squared. So what it's asking us is compared to what we got in part D and E, which would be these right here. Let's ask, does the apple pass through 0.1.80 meters above our hand? So we have to compare what our maxes are, and we'll see if it does pass through at all. So I'm going to take 0.33 over here. I'm going to do 5.50 times 0.33. Now I'm going to calculate this all at once. We'll have multiple decimals, but I'm going to write it out a bit more. Plus 1/2, which we know 1/2 is going to be 4.9. So it's going to be negative 4.9 times 0.333 squared. All in parentheses. Which did this weird for some reason. All parentheses. So all that together, 1.28. So our y max at that time is going to be 1.29 at lowest, which would be 1.30 meters. And then max again, 0.50. Let's say our smaller one, which is 0.285. 285 plus 1/2 of negative 9.8. 0.285 squared. Let me rewrite this. I wrote that a bit wrong. 5. just going to adjust here to a 5 in the calculation. We know this is basic arithmetic in PEMDAS. 1.69, which I think, did I get this correct? That was, yeah. So we're getting 1.29, which is greater than 1.16, 1.17. We know that this won't be passing through. So as this number, when we calculate y max from what we got for part F, we won't be able to, it will be greater, so they won't be reaching the same point. When we calculate from the other one, what we did get from part D, it's going to be smaller, so it would be as if 1.8 would be higher up and would never pass through. So through the question, the apple does not pass through that point. So let's move on to the next part. Move on to part G. Now, this is going to be a bit more conceptualizing. We're throwing an orange up somewhere, so we're going to throw an orange straight up. It's going to be our game. We'll throwing things here. We're going to throw it straight up. T is equal to 0. And then it's going to be at pretty much our height. So let me actually read out what the question asks is. You throw an orange straight up. The orange leaves your hand at time t is equal to 0, moving at speed a velocity. At what time is the orange at a height of 2, or velocity squared, initial velocity squared over 2g. So our height is equal to this. And this is going to be our height. So we have to think, when is this going to reach it? Okay, so v squared to 2g. Now, what we can do, if we have this right here, we can do, so this is our height, so we know that our y initial, or not our y initial, but our y final is going to be this. So v squared 0 over 2g is going to be equal to just our normal equation. But this time, instead of numbers or anything else that we're doing, we're just looking at this with the variables that we usually have. Which how the equation is, which is y is equal to y initial plus velocity initial times time plus 1/2 of our acceleration, which is g t squared. So velocity, we know that our y initial is 0, so velocity times time plus 1/2 g t squared. It's going to be equal to. So what we can do over here is we can take our velocity times t, and what we can start doing is actually start simplifying things over here. We can multiply 2g on both sides. Now we're at velocity squared initial is equal to 2 velocity, or 2g velocity initial times t plus 1/2 of, or actually the 2 cancels out the 1/2, so we're just having plus g squared t squared. So we have this right here. And we pretty much can do the same thing, where we just bring everything over, we just subtract both of these, bring it to the other side. So negative g squared t squared minus 2g velocity times time plus our velocity initial squared, which is equal to 0. And we can actually put this into quadratic formula and figure out what our answer can be, and we can then figure out let's say when it's asking us at what point is it going to be moving upward, downward, or neither. And we can figure out what's at this height right here. What is it going to be doing? So G, this is still going to be E, R A, and R C. So B negative is still going to be positive, so it's going to be 2 G B 0 plus or minus the square root of this right here. G initial squared minus 4 to be G squared times V initial squared. So if we square this, G squared is going to be 4. This is going to turn into G squared, and our velocity initial is also going to turn into velocity initial squared minus the same thing. Velocity initial squared plus or minus square root 2G0 all over G squared. Actually 2G squared because it's going to be 2A. And 2A, which would be 2 times G squared. So since these are going to be the exact same, they cancel out. It's going to be the square root of 0. Square root of 0 is just 0. So plus or minus 0 does nothing. You are just adding or subtracting by nothing. So you are ultimately left with 2G velocity 0 all over 2G squared, which does cancel. 2's cancel, and the G's cancel out. This turns into 0 since this is 1. Turns into 0. This turns into 1. So we're going to be left with velocity over gravity. And that's going to be pretty much our time right here. Time is going to be that. So if we ask ourselves, when will it reach? So if our time is velocity over gravity, we re-plug this back in, and we want to figure out what's going to reach over here. If it's going to be up or down, or it's going to be moving in any direction. We want to figure that out. So V, since that's our time, V initial times V initial over G plus 1/2 G times V initial over G squared. This becomes V initial squared over G plus V squared, G squared. Will actually turn into V squared over G plus 1/2. Plus 1/2, which would be just 2G there. And since we're adding 2 of the same thing, it's just going to give us V squared 2G. So since this was all equal to 0 and our height that was given is pretty much the exact same, equals to 0, that means that when we get all the way over here, it's just going to reach the top point, 0. It will reach this point once. With this height of V initial squared over 2G, it will only reach this once and stop there, and then pretty much move either way with some other y value. Part G. And as well, it also answers part H as well. As we solve this already, we got V initial over G, because part H is asking us at what time does the orange reach this point that we're throwing, and we already figure out that this over here is our time. So we have our answer here. So we figured out already both here for part G and part H. And now we're pretty much going to be doing it the same time for I and part J. They both work in tandem. But this time our height is going to be 3 b squared initial over 8 g. So what we can always do is pretty much just the same formula. So we're going to diagram this out again. We got ourselves throwing this orange. Now our height over here. So our orange is at a height of 3 velocity initial squared over 8g. And we have to say to ourselves exactly at what point, where is it going to move upward, downward, or neither, at what times. Now, if we saw that v squared 0 over 2g was equal to 0, that means to be at this constant point only one time it needs to be equal to pretty much this. Now, we have the same things here, so we can, our v squared initial and g, we can kind of ignore those. Take those out of the picture and let's look at the numbers that is actually in the ratio right here. A variable will always have 1 attached to it. So our variable is actually 1/2. Now, if we see right here, we're going to be comparing 1/2 to the numbers right here, which will be 3 over 8. And 3 over 8 is going to be less than a half. So we know that this is not going to be its total height. So it is going to be able to reach 2 different points. We have a height. So pretty much v squared initial over 2g is the highest you can go. It is our max for this. So we know that 3v0 squared over 8g, since it's a lower ratio, it's going to be lower than our actual max height. It's going to be a bit lower. And since we know it's a bit lower, it can reach 2 different points over here. It reaches 2 different points. We know that the orange will be able to pass through it twice. It's going to be moving once upward over this way and once downward over this way. So let's now show this that we're going to have 2 different times when we input this max height as our, we're going to find out our times. We're going to find out we have 2 different points that make sense. So 3 velocity initial squared over 8g is equal to our same thing, which is velocity initial times t plus 1/2 of g times t squared. So what we can do, we can multiply 8g on both sides. 3 velocity initial squared would that be equal to 8g velocity initial times t. 1/2 divided by a, or 1/2 times 8 is going to be 4. So this will be plus 4 g times g squared of t squared. Subtract everything over to the other side, so minus. We're now left with our final equation, minus 4 g squared t squared minus 8 g velocity initial times t plus 3 velocity initial squared. All right, so now let's replug all this into the quadratic formula, which we have our b, we have our a, this is all b, and we have our a, our c. This is our c up here. So our a, our b, and our c. So negative, it's going to be positive. So 8g velocity initial plus or minus the square root of 8g velocity initial squared minus 4 times, well, we have negative 4 over here, negative 4g. 4g squared. It's squared times 3 velocity initial squared. Velocity initial squared. All right. Then, so 8 is on 8 squared, 64. So we're going to have 64. It's g squared, will now become g squared. Velocity will now become velocity squared. Minus 4 times 3 be 48. So minus 48 g squared v0 squared. So these are now the same, pretty much. Plus or minus 8g velocity initial all over our a, which is 4, which can be just 8. Just 8g squared. Right, so 64 minus 48 is going to give us 16. So 16, and then we get to square it. So 16 squared. Answer can give us 4. So, and then g squared is going to be squared over to g. Velocity initial squared is going to be square rooted to just velocity initial. So we're going to be left with 8 gv0 plus or minus 4. And then gv0. It's a good thing because that means that they are the same and they can be subtracted or added all over 8g squared. So we can do 8 plus 4, which would be 12. So we get 12g velocity initial all over 8g squared, which we can take out our g's, and we can have our v's. So 12 to 8, 12 divided by 8, we take that into a 9 over 4. Or what we can do instead, no, it's 12, that's 18 actually, whoops, that's why I was off. 3 over 2, because what I was going to say is that we can simplify these into 3 over 2. We have just g and velocity initial. So this is going to be one of our times right here. And that's it when they're added. Now let's say that we subtract. We're going to be left with v, or 4 gv0 all over 8 gv0. So take those out. We have a squared over here. Take it out, take out the g. And we left with v0 velocity initial over 2. And that's our second time right there. And now that is all the parts of this solved. So that is question 3, chapter 1 to 2. And that is all of everything solved and worked out. Thank you very much.